Okay, so most projectiles that we will see will not launch horizontally. They'll launch at some kind of an angle. I don't know, maybe not all. Okay, so what you need to do is you need to be able to deal with an initial velocity that is on an angle, all right? So for example, look at this one down here. See, this one just has a horizontal velocity like we were doing before, okay? But oftentimes I'm gonna launch something up like the little bunny in the little video today, or I'm gonna launch something up at an angle, all right? So to do that, you're gonna need to be able to split up into components, okay? Which is V naught in the X direction and V naught in the Y direction, okay? This isn't a great picture though, because this should kind of line up, right? Like the lengths of these should kind of line up and make like a little box there, okay? All right, so oftentimes this angle is given. Sometimes you have to find that angle, which is a little tougher, but not usually, okay? So I like to think of it like, here's my V naught X is like this, and my V naught Y is like this, right? Because if I have this vector here, right, that has a certain length and a direction, I can just slide it over to here and it's still the same vector, okay? Same thing with this one. This vector of a certain size or length, magnitude, and direction, I can just sort of slide over here. So I can sort of reorganize them so they make a triangle, all right? So then all you're gonna do is most likely the V naught will be given and the angle will be given, okay? Not always, but often, all right? So if that's the case, you need to split it up into its components, all right? So probably this isn't that hard for you guys. So I would think of it as I'm gonna go like this. Cosine theta is adjacent over hypotenuse, okay, which is V naught X over V naught, right? Because here's my adjacent side is my V naught X and my hypotenuse is V naught, all right? So then I would end up having V naught equals V naught X equals V naught cos 30. Okay, similarly, I can do the same thing with sine, V naught Y over V naught. So the V naught Y equals V naught sine 30. Okay, and almost always the cosine goes with the X and the sine goes with the Y, right? Because most likely they're giving you this angle right here, this theta, okay? If they don't, then you have to be careful. But in this case, mostly they do, all right? So if you just want to kind of skip writing all this cosine stuff, it's very common for you just to look at this problem and then write the components out, right? You don't have to show all this work, right? That's a pretty common thing that me or any AP reader would know, that you just look at that and you just write those components like that, okay? If those values are given, right, you could go ahead and get a number for these and then just use those in your table, okay? Sometimes you might have to leave it in variables if it's not solvable, like already, okay? All right, so you can do the same thing on the bottom, which is kind of what we did in the last class, right? When you have something landing, it would be the same thing. You'd have your Vx, which is the same as your V naught X, and then you'd find your final Y, okay? And then we will kind of draw that triangle. Oops, what is going on? Okay, and then there's gonna be your component like that, your V final. Okay, so again, if you wanna slide those vectors into a triangle, right, I can slide that one, V naught X, okay? And then if I want to think of this one too, here's my V naught Y, I can just, whoops, that's not where I want to put it. I can slide my V naught Y over to here, or my V final Y, okay? And then I'm going to connect those up into the triangle. All right, so you just want to make sure that your resultant is pointing the right way, okay? Because you're adding these vectors, what we call head to tail, right? So here we go, there's the head, and then there's the tail, all right? And then you're gonna find this angle. Okay, so you can just use Pythagorean theorem, right, to find the magnitude, okay? And then the theta, most likely you're gonna use tangent theta, which would be VFY over V naught X, okay? And then you'd solve for your theta, whatever that is. Okay, that's if it asks you. And it almost always we do like this, we do below the horizontal. Okay, is usually how it's said. That's that angle right there is the one that you're trying to find. All right.